The K, the L, the M, the N, the O, the P, the Q represent the first, the second, the third, and so on and so forth energy level. How many electrons are in each one? Now again, for the first two, look for everything that has a 1 in front of it, add up all the electrons. Then for the L, look for everything that has a 2 in front of it, add up all the electrons. Shenza. What? Oh, did I have the wrong one down for that? Okay, so just ignore the symbol for it. I'll fix it right now.
Los grandes. 4 y 4. ¿Qué tienen arriba? 8. Ok, se lo pones. 4 y 4. Le pones 8. ¿Qué más, pendejo? 4.
¿Por qué 4?
8.
8. 8?
Sí.
8.
8 en el cuarto, sí. En la gente, pendejo, cuenta 1. No, pero tienes un 4 más. Tienes un 4 más. El último.
Oh, yeah, 8.
Thank you, Shenza.
No, pendejo. Los números de arriba.
Oh, okay, so
6, 2 y 9.
4 con 2, 2S y 2B, right? Okay. Y luego
4D y 4D9.
¿Pero por qué S?
Porque tiene un 4 enfrente, pendejo.
¿Y también 4B?
Sí.
So that's 16. No, 12.
Pendejo, no. Oye, sí.
So, 4,
17, pendejo.
¿Cómo 17? 4B, 4D.
6 más 2 más 9.
6 más 2 más 9. Oh, okay. So, 17 en total por N.
Now, in reality, ladies and gentlemen, this is a fairly easy thing to do, but you just got to be careful. So if you're sitting there going, well, how do you go about doing this? Okay. First of all, if you don't use the noble gas cores, which you don't have to, you can, you may choose not to. But if you don't use them, ladies and gentlemen, at least this part does become a little bit easier, but you still got to be careful with some things. So the K energy level, ladies and gentlemen, represents anything that is in the first level. So you're looking with anything that begins with a 1. For the L level, that represents the second level. You're looking for anything that has a 2 to start it. For the third level, that is anything that has, or the M is the third level. Now, here's where you need to be careful, because you've got these, the 3S and the 3P here, but you've also got a 3D here a little bit further along. Those all get added up together for the M. For the fourth level, ladies and gentlemen, again, you've got the 4S's here, the 4P's here, and then you've got the 4D's here. So you just need to be careful and add up everything. And when I talk about adding up everything, ladies and gentlemen, what I'm really talking about is adding up the powers. Okay? These numbers here. Okay? So for 1s2, that means that first level has 2 electrons. By the way, the first level has to be filled before you would go to the second. The first level fills with 2. So if your element isn't helium or hydrogen, and even if it's helium, first level gets 2 electrons. The only atom that doesn't have 2 electrons in the first level is hydrogen. That's it. That's the only one. The second level is full here with 2 and 6, which gives you 8. The L will never have a number by it larger than an 8. Now the M can have up to 18. Up to 18. Doesn't mean it has to have 18. But we've got 2, 6, and 10, so it does have 18. The N has 2, 6, and 9 for a total of 17. But it could hold how many? 32. So we're still well below the limit. And then finally, in the fifth level, ladies and gentlemen, the one I didn't highlight here, there are 2. So again, your last number always has to be between 1 and 8. The ones before it don't. But the last one has to be between 1 and 8. Questions? Now with that in mind, make sure you double check number 2 here, ladies and gentlemen. Okay? Make sure you double check number 2 here. Okay. So for number 2, ladies and gentlemen. All right. Ariana, how many in the S? Or how many in the K? Sorry. 2. How many in the L? And how many in the M?
4.
Good. Here are the 2 that are in the first. There are the 8 that are in the second. These 4 are left over to go into the third. Questions? Okay. Now if we use a noble gas core, again, we need to account for those first 36 electrons. So if you look at your periodic table, next to the element krypton, there are numbers next to it. Tell me what the 4 numbers next to krypton are, Achilles. 2, 8, 18, and 8. That takes care of these 36 electrons right here, ladies and gentlemen. So now, in the 5th energy level, we have how many more? 7. So that goes in the O. And if nothing else, count over. 1, 2, 3, 4, 5. That's the 5th level then. But there are also 4 or 10 more that go in the 4th level. So even though we put an 8 here, because that's what there was for krypton, now we filled 10 more spots in that energy level. So that makes this an 18. So 2, 8, 18, and 18. That is 46. Plus 7 is 53. That's how many there should be for iodine. Questions? Yes, no, or maybe so. Any questions at all? So here's what I want you to do now. This is an atom, calcium. We have taught you that calcium is in a certain part of the periodic table. So when calcium goes into a compound, it will have a certain charge to it. I want you to tell me what charge each of those atoms would have when they go into a compound. When they become part of a compound. What will their charge be? Now, originally, atoms start out with their protons and neutrons what?
The same.
I'm sorry. They're protons and electrons.
The same.
The same. Not neutrons. My bad. Get that out of your head. Protons and electrons are the same because every atom starts out neutral. Everyone begins neutral. And one of the things that I haven't stressed enough is in a balanced chemical equation, if iron is a metal, it does not have a charge. It doesn't have a charge until it combines with something else and becomes part of a compound. So originally, calcium has how many protons? 20. So how many electrons would it have?
20.
20. My question is, what charge does calcium have when it goes into a compound? So, +1, +2, +3, +4, -4, -3, -2, -1. And I can't do this to you and give you one that's in the middle. In the transition metals. There's only two that I could give you in there. What would they be? What are the only two that I've told you they're charged, even though they're transition metals?
Zinc and silver.
Zinc and silver. Those I could give you, but I'm not. Okay? So I want you to tell me what their charge would be based on the family that they're in. And then I want you to tell me how many total electrons they would have. Now remember, atoms can either gain or lose electrons to become charged. So if you become a charge of a +2, what does that mean for your total number of electrons? Take a minute, fill this out. You need more time, ladies and gentlemen? Is utter silence a yes or is that a no? No? We're good? Wow. You guys are just the vocal group of the year today. Okay, so let's go through this then. All right, let's begin with this, ladies and gentlemen. What's the charge on calcium? Calcium is a +2. What's the charge on sulfur? -2. What is the charge on chlorine? What is the charge on magnesium? And what is the charge on fluorine? -1. If calcium has a +2 charge, what does that mean that it has done with the electrons? Gained or lost? Lost. You lose electrons, you become positively charged. Why? Well, you start out with your protons and your electrons equal. 20 protons, 20 electrons. The only way you can have a positive charge is if you have more of what? More protons. They have the positive charge. Okay, that is the only way you can be positive. Now, you cannot gain or lose protons. Why? And what would that do to the atom if you gained or lost protons? It would change what atom it is. We don't do that unless we're talking about nuclear reactions, which we will later. So the only way an atom can become charged is by gaining or losing electrons. So to be positively charged, you have to have more what? Protons. So how many electrons does calcium have to lose to become a +2 charge? 2. So how many would it then have if it started out with 20 and lost 2? It would have 18. Now, sulfur is a nonmetal. Nonmetals do what with electrons? Well, calcium was a metal, and it just did what? It lost. So nonmetals must gain, and that is how they become negatively charged. Sulfur has 16 protons and 16 electrons, correct? To become negatively charged, you're going to have more of these. So, to become a -2, how many total electrons does sulfur have? How about chlorine? How about magnesium? How about fluorine? So, ladies and gentlemen, let me get this straight. Calcium becomes a +2 and has how many total electrons? 18. What about potassium? What charge would it have?
+1.
And how many electrons would it have? All right. What about gallium?
+3.
Okay. How many electrons does it have? 31. So what would it have then?
38.
What?
28.
28. Okay. Chlorine, -1. How many electrons? Nope.
17.
Nope. 18 when it is a -1. Sorry. Sulfur was a -2. How many electrons? Phosphorus.
-3.
How many total electrons? How about silicon?
-18.
What are we noticing, ladies and gentlemen? They're all 18. Now, what element is 18?
Argon.
So tell me the electron configuration for argon. No. Give me the whole thing, not just the 288. Give me the whole thing. 1s2.
2s2, 2p6, 3s2, 3p6.
Okay, correct? Right? Okay, good. So give me number 20, calcium.
1s2, 2s2, 2p6, 3s2, 3p6, 4s2.
Okay, we're good there, correct? Yes? Give me the configuration for calcium as a +2 ion.
1s2, 2s2, 2p6, 3s2, 3p6.
Wait a minute. What do you notice about those? They're exactly the same, aren't they? Exactly. What do you think the electron configuration for potassium as a +1 ion would be?
The same.
What about chlorine as a -1 ion? What about sulfur as a -2? What about phosphorus as a -3? When atoms become stable, when they combine, the reason they are combining is to become stable by gaining, losing, or sharing electrons, right? So what does every atom look like when it becomes stable?
The same.
What?
The same.
What does calcium look like when it becomes stable? They all look like a noble gas. They all look like a noble gas, ladies and gentlemen. They look like a noble gas. That's why they are losing electrons or gaining electrons to become stable like the noble gases already are. We have a term for this, ladies and gentlemen. The term is isoelectric. The term is isoelectric. It's a good idea to write that down. Isoelectric, ladies and gentlemen. That is the term for it. It is an ionic form of an atom having the same configuration as a noble gas. The ionic form of an atom having the same electron configuration as a noble gas. That is the definition of being isoelectric. When lithium becomes stable, it's going to do what?
Look like another gas.
Which one?
Yeah.
Oh, which one's it going to look like? It's going to look like helium because lithium has one valence electron. It's going to lose it. Well, if it had 3 electrons originally and it loses 1, it's down to 2. What will beryllium look like when it becomes stable? What? Helium. What will carbon look like when it becomes stable? Neon. What about nitrogen? What about oxygen? What about fluorine? What about sodium? Neon. What about magnesium? What about aluminum?
No, no.
Still neon. What about silicon? Oh, not neon. Silicon's going to gain electrons. It's going to look like argon. What's phosphorus going to look like? Chlorine's going to look like. So tell me what that pattern is. What do the metals do?
Metals are noble gases by.
The noble gases at the row above them.
Yeah.
Metals are the noble gases at the row above them. Above them. But non-metals are what? Same row. Same row. Iodine will be isoelectric to xenon. Go ahead, Josh.
What about germanium and antimony? Are those just special cases?
Yeah, kind of. Why? Because if you look at even gallium, gallium's going to lose how many electrons? But it goes down to having how many? 28. That's not the same as argon, is it? Which is 18. So because those D's have filled, it's not going to look exactly like the noble gases. So there are a few exceptions to this. But these over here, and before you start filling the D's, yes, they look like the noble gases above them. These, even though the D's are already filling here, will still look like the noble gases at the end because the noble gases at the end already have the D's in them. Okay? So it's a term, it means isoelectric. And what it really means is it looks like the noble gas either in the row above it if it's a metal or at the end of its row if it's a non-metal. So fluorine as a -1 would be 1s2, 2s2, 2p6, the same as neon. So would sodium. Why? Sodium has lost the 3s1. Fluorine is gained from p25 to become p26. It has gained 1 electron. Sodium has lost 1. Oxygen will gain 2. So instead of 2p4, gains 2 electrons. Now it looks just like neon. So does magnesium. But because it lost the 3s2s. So does nitrogen. So does aluminum. They are all isoelectric to neon. Okay? And that's what the term isoelectric means. So it wouldn't surprise me if on a test, the only one you have left in here, there was a question that says branium is isoelectric to fermium when it loses 2 electrons. So first of all, where are you going to be if you lose 2 electrons? Where?
Row 2.
What?
Row 2.
Not row 2.
Just the left side.
Where? Where are the ones that lose 2?
Column.
Row 2.
Group 2, column 2. They lose 2. So if it's in column 2, where would fermium have to be compared to branium if branium is isoelectric to fermium is a +2? And fermium has to be a what? A noble gas. So if fermium's already on the table, say it was right there, where would branium go? Where calcium is. But if branium were there, what clue would you be placing? That fermium is argon. Oh my, this is going to be fun. This is going to be fun. Okay? Now, I just gave you a periodic table, ladies and gentlemen. The one that I promised I would give you yesterday. So let's take a look at it. Well, before we do, though, let me finish out this slide only because it's kind of cool. Okay? So, again, sulfur would be isoelectric to argon. Why? Because argon is the noble gas at the end of the same row sulfur is in. Chlorine, isoelectric to argon. Potassium, isoelectric to argon. Calcium, isoelectric to argon. We're not going to go and say gallium, though. Right? Gallium doesn't fit that. Okay? Questions? Okay. So, let's put a little bit of notes on here. Some things you may or may not have forgotten. Some things you may or may not know. And again, as I'm putting the notes on here, ladies and gentlemen, if you're like, oh, Mr. Brent, I got that down. Please don't write it then. Well, I don't care. I'm just trying to help you here. Okay? So, ladies and gentlemen, oh, what color? What color? What color? Pink, orange, or a burgundy? Pink. Okay. It's not really a hot pink, but it's a pink. We'll go with it. Okay, ladies and gentlemen, here we go. Here we go. So what we're doing on this side of the table, we're putting things on here that represent anything going up and down in this family. It could be called a family. It could be called a group. So let's begin with this. Group 1. All have 1 VE. What is VE? Valence electron. If you need to write what VE means, please put a note somewhere on here for you. I don't. I know what VE means. That means it has one electron in its outer shell. One. By the way, what is that going to mean for charge? +1. Okay? So what are we going to write in group 2? We're going to put 2 valence electrons. And then under it, we're going to put +2. Okay? Now, we already have somewhere written on our periodic table that metals always do what? Lose, become cations, become positive. So, hopefully you don't need, if you need to put a note on here that says that as well, go ahead, but hopefully you understand that. Group 13, 3 valence electrons +3. But there is an exception here. Which one does not follow that rule? Boron. Good. Group 14, 4 valence electrons +4 / -4. What would be the -4s? The nonmetals. The metals would be the +4. 15, 5 valence electrons -3. Again, not counting the metals at the bottom because they are exceptions. Group 16, 6 valence electrons -2. Group 17, 7 valence electrons -1. And group 18, 8 valence electrons, asterisk. Why? Come on, come on. Must be an exception if I put an asterisk by it. Every one of those in the noble gases have 8 valence electrons. Every one of those in the noble gases have 8 valence electrons. Thank you. Helium only has 2. But it's still what? And it's still what? It's still stable. It's still filled because the first level can only hold how many? 2. So they have no charge. Questions? Yes, no, maybe so? All righty, wonderful. Again, ladies and gentlemen, you can add as much to this as you want or as little to this as you want. You want another one of these? I'll give you another one of these. All of which can be used on any quizzes or any tests from here on out. Well, the most we're going to have is maybe one more quiz. I don't know if we'll have one next week or not. And then the week after that, we're going to be taking our test because 2 weeks from today, you will be done with me. I know. Yeah, I know. Maddie's got a big old smile on her face like, thank God. Okay? So 2 more weeks, you'll be done with me, ladies and gentlemen. And since not enough of you signed up for AP Chem, which is okay because I didn't really want to teach it. I've never taught it before anyway. You will be done with me. Okay? Questions? Okay. It's okay. I'm not going to hold it against you that you didn't sign up for AP Chem. I never took AP Chem. Now, I had to take nuclear physics and radiochemistry in college, but that was no fun. What's the matter?
Me and Chinzo both signed up for AP Chem, but we got an email that was like,
Yeah, I think it was up to like 8 or 9,
yeah, and they're like, oh,
but not enough.
They don't want you in a class with Mr. Brown with 8 kids.
Yeah, that would not be a good thing. Well, here's the fact. It still comes down to budget. They're not going to pay me to teach a class of 8. They can't. So,
I have a class of 10.
what?
I have a class of 10.
What's the class?
Spanish 4.
Yeah, and that is basically like an AP class. So when you get to that 10 to 12 range, they will consider running them. Okay? All right, ladies and gentlemen. I told you earlier that we were going to talk about or kind of explain to you the weird things that go on in here. Okay? How can one atom have multiple different charges? Well, this is the explanation, and it comes down to all electron configurations, and it comes down to electrons fill the what? Lowest energy levels first, right? Okay. So there is this thing that we found. We didn't want it to be. We found that it happens, and it lets us explain how you can have copper as a +1 and copper as a +2. And they are called degenerate orbitals. They are called degenerate orbitals. Now, later on in the next week, we're going to have to talk about degenerate orbitals when it comes to the geometry of some atoms or some molecules.
You're in geometry now?
Yes.
No, we are.
Yes. Tetrahedral, trigonal planar, linear, bent,
I failed it.
trigonal pyramidal. Okay. Don't worry. I got easy geometry for you. Okay. Okay. So the electrons sometimes, even though they fill the lowest energy level first, sometimes one level is close to another. So what that means is occasionally we found that sometimes electrons get what we call promoted. They get moved up to a higher level even though they shouldn't. Why? The levels are very close. The energies are very close. And we already said electrons are doing what to each other? Repelling. So that kind of works in their favor to want to get away from each other and move up to a different level. So an electron can get promoted into the pz orbital from the s orbital because of the close energies between the two orbitals. Okay? So sometimes electrons can get promoted up. This happens to fill Hund's rule of singly first and then doubly. Okay, so here is the way we would write copper. 1s2, 2s2, 2p's, the three orientations would be filled. The 3s is filled. The 3p's are filled. px, py, pz, 6 electrons. And then sometimes copper is supposed to have 2 here, correct? 4 s's should fill before the 3d's, correct? No. Which would make it 3d9 like it is down here, right? But if copper takes that one electron that's in the 4s and says, you know what, go there just to fill that because there's still 2 here either way. Well, now, how many valence electrons does copper have? 1. Because remember, this is the outer level, correct? This is still part of the third level, right? Well, if it loses this one, it's going to have a +1 charge. That's the only way we can explain it. Okay, there should have been 2 there, but it only loses 1. Why? Where'd the other one go? It had to go fill in here. It had to go fill in here. Okay? And I'm telling you this not because I expect you to know when this happens. I'm not telling you this because I expect you to be able to predict this. I'm telling you this so that later on when we're talking about those geometries that Phoebe's so excited about, you can understand why it does what it does, because it's one of these degenerate orbitals. Okay? If it doesn't send that electron here, now it has 2 in the outer shell, 2 valence electrons, and sometimes copper will lose both of them and act like a +2 charge. So sometimes copper acts like a +1. Here's our explanation. There's only 1 in the 4s because 1 got promoted up to the 3d. And if that doesn't happen, well, it sometimes loses them both. Okay? We don't know exactly why, but it's the only explanation we can do to say, okay, here's how it has multiple charges. And it gets more confusing when you get to chromium, which can have a charge of +1, +2, +5, +6. We're not even going to worry about it. But this is the best we can do. But it also helps validate that model of quantum numbers, that it can explain something like this happening. Okay? Questions? None? 0 zip zilch? We're all good? Okay. All right. So that's the last thing I got for you today, ladies and gentlemen. That's the last thing I got for you today. All right. For us to take our quiz today, ladies and gentlemen, part of it is on paper and part of it is on your computer. So you are going to need to take out your computers. You are going to need to get logged in. I will put the quiz out there. Okay. There are 15 points. Dude, you are a...
It lowered down.
It's going to lower down. That's what batteries do, is you use them.
Yeah, that's 28.
Oh my God, that's only an hour and a half left.
It's a minute.
That's not minute, dude.
5 minutes and 1. Yes, it is.
So ridiculous. Okay, now you can take out any sheets that you want that you have notes on, ladies and gentlemen. You can use them on the quiz. Okay, so again, I'm not making you take and put all your stuff under your desk. You can take whatever you want out and put it on your desk. Okay. I will hand out the sheet to you. The sheet, you have 5 electron configurations to do. I don't care if you use noble gas cores. I don't care if you don't. It's your choice. But understand this. If you have something wrong, the whole thing is wrong. You either get it right or you don't. If you use a noble gas core, remember you have to put the number of electrons by it. So for neon, 10. Argon, 18. So on and so forth. When you're done, you should be able to add up all of those exponents, all of those powers, and get to the correct number of electrons. And nothing is isoelectric here, so you don't have to worry about a +2 or a -2 or anything like that. They're all just the neutral atoms. Okay? Questions? Okay, I just assigned the multiple choice question portion of the quiz in Google Classroom. You can get started on that. I will bring these around. I will put them on your desk. Please remember to put your name on this because I will not know whose is whose when you put them up in the front. Yes? What? I will go get you a charging block.
Josh, did I give you one?
Yeah.
You're welcome. You're welcome.